Good afternoon. Good afternoon. How's everybody? Happy Wednesday. All right. While we're waiting for everybody to come in, we're going to move on to 4.4. So if you can give that a look on Canvas while we're waiting. Some of you have not turned in your FRQ, so you can do that. We are going to, um, okay. All right. So just know that we're doing a 4.4. I only just signed it on the AP Classroom, so hopefully by the time we finish watching the video and looking at Canvas, it will be because it available to you. I forget I need to do that an hour before you get to class and not when you get to class because their time is different from our time. I wonder what's going to happen when we turn the clocks spring forward ahead. What time it'll be then? We'll see. We will see. But in the meantime, if you would read over, if you've already done everything you need to do, if you would read over 4.4 while we wait on folks to log in. So let's see what is after this. All right, pay particular attention to this part. You do have to know the layers of the atmosphere. You do need to know them in order, and you need to know what's going on in each layer. And by that, I mean, for example, we live in the troposphere. Planes fly between the troposphere and the stratosphere. The ozone layer is not one of the layers of the atmosphere, but it is a layer within the atmosphere between the stratosphere and troposphere. So things like that you need to know. So just click on all these little buttons and read what it has to say. Know what layer the meteors are going to be in. That's these things flying around over here. And we have our satellites running around outside in the exosphere. So those are the kind of things you need to be aware of as far as the atmosphere is concerned. Still waiting on. I'll give another 5 minutes. Still a few people out now. So in about 5 minutes, I'll do attendance and then I'll do the 4.4. All right, so it may seem like they have this backwards, but what they've done is gone from outermost layer to innermost layer. Know the composition of the atmosphere. This is important. All right, everybody's lithosphere web quiz should be in by now. Um, ones that were turned in this week are excused late, but after this, it's late because it's been late. But I excuse the late up until today. So please make sure that gets turned in if you haven't already done so. The most current assignment are the FRQs for 4.1 and 2. Okay. And those of you who made changes in the AP classroom, I will check on those. Yeah, okay. Gotcha. I will check on those while you're working in the AP classroom. All right. All right, so I'm going to stop sharing for a minute, do attendance, then come back, and then we will do 4 point just in time. I will come back and do 4 point 4.4. So again, if you just came in, please read over 4.4 in Canvas and giving particular attention to the layers of the atmosphere. And we'll proceed with the lesson in a few minutes, as soon as I do attendance. As soon as I finish authorizing doing attendance. Okay. What else is not here? Oops, there's one. That being said, back over here. All right. So again, for those of you who just joined us, we are moving on to 4.4, which is about the atmosphere. So we were talking about soil, and now we are talking about the atmosphere. So we've gone from the ground to the sky. The key points in the atmosphere is to know about air pressure and how it's measured, what the air is made up of, and So this section right here, the components, and most of us think oxygen is the most, but it is not. Nitrogen is the most abundant gas in the atmosphere. We just exhale it. So we inhale it, but we exhale it because the body doesn't use it like that. We need it, but we get our nitrogen from the things we eat and not from the air. Okay, so that's important. Again, go through this diagram and know the layers of the atmosphere in order. So when we finish watching the video, come back and click on what's going on in each layer. In particular, you need to remember again that the ozone layer is not is a layer within the layers of the atmosphere. So it's not considered an atmospheric layer, but it is a layer within a layer. So make sure you pay attention to that in your reading. All right, so we will check out what Mr. Smeeds has to say. About this unit.
It all comes down to this run for Red Gerard.
So much style in this run.
Hey everybody, it's Mr. Smeeds, and today we'll be covering topic 4.4, which is the atmosphere. So we'll be focusing on the temperature changes that happen in each layer of the atmosphere and how those changes actually define the layers. So our objective today is to be able to describe the structure and composition of Earth's atmosphere. In order to do that, we need to know what the major gases of Earth's atmosphere are, and we need to know their relative abundances or what percentage of the atmosphere each one makes up. We also need to know that the layers of Earth's atmosphere are based on changing temperature gradients in each one, and we'll talk about why those changes occur at the end of the video. Our suggested science skill for today is to describe characteristics of an environmental concept that's represented visually. So before we talk about Earth's layers, we're going to run through the basic abundance or percentage that each of the gases in Earth's atmosphere represents. So first we have nitrogen at about 78%. Remember though that most of this is in the form of N2 gas, which really isn't reactive or usable for plants on Earth.
That's early for a commercial.
Without being fixed by bacteria in the soil or by humans combusting fossil fuels to create synthetic nitrogen fertilizers. Then we have oxygen next at about 21%. And this is critical for life on Earth, of course, because animals, including humans, use it for respiration. This is a key APES vocab term that we should know. So it's not enough on an FRQ in APES to say that we breathe oxygen. That's just the act of pulling it into our lungs. We need to use the word respire or respiration. We need to know that oxygen for respiration is used to break down glucose to form ATP, which is our main energy source. The third most abundant gas in the atmosphere is actually an inert or non-reactive noble gas called argon, and it's about 0.93%. Then we have water vapor, which depending on the conditions and region can range anywhere from basically 0% all the way up to 4%. It's also important to know that water, even though it naturally occurs in the atmosphere, is actually considered a greenhouse gas, meaning that it traps the sun's energy in the atmosphere and warms the planet. Now, it's not a greenhouse gas that we really need to be concerned about. We don't need to take any actions to reduce water vapor in the atmosphere because, for one, we need water to cycle through the atmosphere so it can precipitate back down to Earth eventually. But also, it moves through the atmosphere quite quickly, so it doesn't persist there for months or years like greenhouse gases that we're more concerned about. And the final gas we'll talk about today is carbon dioxide or CO2. So you may be thinking, well, it's only 0.04% of the atmosphere. But it actually has a tremendous impact on the temperature because it traps the heat coming from the Earth's surface, heated by the sun's rays, and it increases the temperature of the atmosphere. That will increase the temperature on land and in the oceans. So we'll really talk all year about how increasing CO2 levels in the atmosphere impact ecosystems all over the world.
Really cute.
So before we look at the temperature gradient that defines Earth's atmospheric layers. We're going to go through each layer and talk about some of the basic characteristics of them so we're familiar with them. So the troposphere is the layer closest to Earth's surface, and it's where all of Earth's weather takes place. It extends up to about 16 kilometers from Earth, and you can remember that the weather takes place here because the prefix tropo comes from the Greek phrase tropos, which means to change. And as we know, weather is always changing. It's also the densest layer by far because it's the closest to Earth. So the majority of the Earth's water vapor is going to be found in this layer of the atmosphere, along with many other gases.
All right, I wanted to pause it there. When he says dense, and this is one of those questions that they're going to ask you. Dense gases can be squished together. One of those, we have our stages of matter, solid, liquid, and gas takes up the space of its container, except being as this is the layer that's on the bottom, all the other layers above it add pressure to it, so there are more molecules of gas in the troposphere, so that's what they mean by the densest layer. As you go up, there's less pressure, so the molecules can spread out a little more, so they are less dense.
And while ozone is really beneficial in the stratosphere, where it forms a protective layer that blocks us from a lot of cancer-causing UV rays, when ozone forms down near Earth's surface in the troposphere, it's actually considered an air pollutant. Now that's because it contributes to the formation of smog. It damages the human respiratory tract, so it can irritate our esophagus, it can damage our lungs, and it can damage the stomata of plants. And these are little pores that the plants use in their leaves for taking in CO2 and releasing oxygen. So ozone in the troposphere can be really harmful to humans and plants. Then we have the stratosphere, and you can remember S for second, since it's the second layer of the atmosphere. The most notable thing about the stratosphere is the dense ozone layer that forms here, which I mentioned earlier, helps block UV radiation. So that's really beneficial for life on Earth. Then we have the mesosphere, and you can remember M for middle. And it's important to point out here that with each layer up we move in the atmosphere, the gas molecules get less and less dense as they're further from Earth, and there's also less mass from layers above them pushing them down. Then above the mesosphere, we have the thermosphere, and I like to remember that therm refers to heat, and this is the hottest layer. It also absorbs highly damaging X-rays and UV rays, which is vital for life on Earth since those rays could damage our tissues and even be deadly to some organisms. This layer also contains charged gas molecules that light up when struck by high energy solar radiation. This produces a really neat effect called aurora borealis, or the northern lights. And finally, there's the exosphere. And you can remember that exo means outside, like the exoskeleton of an insect. So this is the outermost layer of the atmosphere, and it's really where the atmosphere merges with outer space. Now we'll take a look at the way that temperature changes within each layer. So it's important to point out that these layers are actually determined by the changes in temperature gradient. So we'll start at the lowest layer and work our way up. And I want you to keep an eye on the graph over to the left and on these red and blue arrows as we go, because they can remind you what's happening to temperature.
It all comes down to this run for Red Gerard.
So much style in this run.
In each layer. So we'll start at the very bottom of the troposphere, right at Earth's surface. And as we move higher up in the troposphere, away from Earth's surface, it gets colder because the Earth's surface is warmed by the sun. And as we're getting further away from it, there's less heat. So think about climbing up a really tall mountain. It's going to get colder as you get closer to the top. So if we look over at our graph to the left here, we'll see that in the troposphere, this bottom layer, as we move up or further from Earth's surface, our line for temperature is going over to the left, which is over towards colder temperatures. So we have a blue arrow here reminding us that as we go up in the troposphere, it's getting colder. Then we have the stratosphere, where it starts to get warmer. So temperature increases as we move up into the stratosphere because the ozone layer at the bottom of the stratosphere is blocking most of the UV rays, which are high energy rays from the sun. These rays, however, hit the top of the stratosphere and warm it up, kind of like the very top layer of a pool in summer or Lake Michigan getting warmed by the sun. So if we look at our graph over here, we can see that after this peak ozone layer, which blocks a lot of those high energy UV rays, the stratosphere is going to start to warm back up quite a bit as we get towards this top layer, which is being warmed, just like a pool in the summer gets warmed by the sun's rays, by these UV rays that are striking the top of it and warming it up. So then we have a red arrow going back up to remind us that in the stratosphere, we're getting warmer as we move up. Then in the mesosphere, it starts to get colder again because the gas molecules in this layer are very spread out. So they just really can't absorb much of the sun's energy very effectively, and so they can't heat up very much. So if we look at the graph of the mesosphere, we'll see that as we are moving up, temperature drops back down, and we're going to actually reach a point called the mesopause, which is about the coldest temperature ever found on Earth. This is about negative 150 degrees Fahrenheit. Then we get to the thermosphere where we're getting closer and closer to the sun, and because this layer is absorbing some very high energy UV rays and X-rays, this is going to cause it to heat up dramatically, up to temperatures as high as 3,100 degrees Fahrenheit. So remember that each layer of Earth's atmosphere is characterized by a shift in temperature in the opposite direction. So just remember, if you start on Earth and climb up a mountain, it starts to get colder. And then with each layer above, that temperature gradient is going to change in the opposite direction. Our science practice for the day is describing characteristics of a concept visually. So I want you to try to identify one of the layers of Earth's atmosphere in the diagram here that has an inverse relationship between temperature and altitude, and then describe why that's the case. All right, everybody. Thanks for tuning in today. Don't forget.
Okay. One day I'm going to ask you to translate what he means like that. Think like a mountain, write like a scholar. That's important for AP writing. That'll be an extra credit question one day. Explain what he means by that. All right, so again, we are in 4.4. There we go. All right, so we are in the atmosphere. So we finished with soil, we finished with the land, the lithosphere, all of those things. And now we've got 2 units under atmosphere. And the atmosphere has been assigned in the AP classroom for you to do. So again, I will combine the 2 FRQs from his videos together at next week. Okay, next week. So for today, go back and read this over again. Density is an issue. So if you remember back from learning, like whenever you had physical science and you learned the properties of a gas it takes the shape of its container again. So it can be pressurized into smaller areas, smaller volumes, or what it likes to do because it has high energy is spread out as far as it can. So as you go up and you release the pressure from the layer above, as he said, the molecules are so spread out that the heat from the sun is not causing them to vibrate. We get heat, molecules vibrate, and that's how they give off heat. So if they're spread, and then because they bounce into one another, they transfer the heat. Well, if they're spread apart, they can't bounce into one another, so it becomes cold from lack of collisions. So this is the picture of the molecules spread apart at the top, and at the bottom of it, at sea level, molecules are closer together. He talked about the layers of the atmosphere, so make sure you go through these and know what the atmosphere is made up of. Again, we tend to think of the air being oxygen. The air is not just as oxygen, and it's not even mostly oxygen. So make sure that you go through and look at this. And again, click on each layer. They've done it in reverse. So we start at the bottom. That is a description of the layer closest to us. Then the stratosphere, the mesosphere. Know what the temperature is, know what's going on in each layer. The thermosphere. Okay, this is the region where the aurora, so no kind of key things. Know where planes fly, know where the ozone layer is located, know where the aurora borealis is, and why we have this effect. Because this is kind of an electromagnetic effect in the Earth's atmosphere. And again, if you click on these, it'll be the same as those up there. All right, So I will stop talking and give you a chance to hop over to the AP classroom. But read this first before you hop over there. I did um, assign the videos, but I'm not sure. I mean, look at what time it is. So right now it's 12:55 here. And okay. Uh, it might be open. Let me know if it's not open. And again, if it's not available to you, you're just gonna have to wait a little while for it to open. But they've been assigned. And I went ahead and assigned the next one just so that it won't be late being for you to have access to it. But you don't have to do 4.5 today, only 4.4. All right, and while you're doing that, I will check on folks who are doing retakes. Folks who had stuff to complete, because everybody, some of you hadn't done them for 1, 2, and 3. So I will be checking on that. Um, I do have 2 of you who did not do the last test. Please let me know if you have access to that. The Unit 3 progress check. Uh, please let me know if you need me to open that again. Right, if you haven't done the FRQs 4.2 and 3, they are due today. So to avoid that 0, if you haven't done it, I would do that first before I do 4.4. So the assignment in Canvas for the FRQs for 4.2 and 4.3, if you have not done them, they're due today. After today, they'll be late. So please give that your attention if that's you. All right, folks, if you're in a good spot to stop, you can go ahead and do so. And I will see you on Friday. I have to keep looking at the calendar since we shifted. Have a good one.